Number 15, we're asked to consider the system of equations. And we'll look at the values for k, like we did earlier in the previous question.
Go to the gym, please. Step to the gym, please.
Where the system has no equations, infinite, or unique. So let's talk about no solutions. No solutions happens if these two things are parallel. In other words, there's a scalar multiple between these pieces, but not these pieces. So the scalar multiple between 1 and 2, to get the x's, is you have to double it. So if I double that, k would have to be 2. Right? That way, if I look at the y's, I get equation 1 would have 2y, equation 2 would be 2 squared, which is 4y, so that's good. And if I look at the coefficients on the other side, I have -1 and 2, and those are not collinear values, because of sign, of course. So k being 2 would work for no solutions, and being parallel. If we look at b, we want to be infinite. In other words, we need this thing to be entirely a scalar multiple. Well, is that possible is the question you have to ask yourself. That is possible if, again, I double the x's, I double the y's, and I double the coefficient on the right-hand side. So how do I do that? Well, let's take a look for a second here. We have x plus 2y equals -1. If I double all those, 2x plus 4y equals 2, creates a situation for part A, right, the parallel. What happens if I make k, instead of being 2, what if I make k -2? What happens then? Well, let's go back for a second here. We're going to make k be -2. What would that look like? I'd have -2 squared y, and -2 over here. And we're assuming that k is -2 here, okay? Well, what does that come out to? Well, 2x, 4y, and -2. Hey, all of this is that times 2, right? So as long as k is -2, I have infinite solutions. I want to make it a unique solution, which means at some point they intersect. In other words, they're not parallel. I can do that as long as k is not 2. That was our no solution issue. And k is not -2, because that would be our infinite solution problem. That's how you can deal with that question.